Welcome. Today we're going to take a look at a foundational IT framework, which when put into practice becomes an incredibly powerful tool for troubleshooting and problem solving, the OSI model. Open Systems Interconnection Model is a conceptual framework that standardizes how different network protocols and devices interact. It breaks down the incredibly complex process of network communication into 7 distinct layers. Think of it as a blueprint for how data travels from one point to another across the network. I would also like to point out that data has been visually structured. Each layer of the OSI relies on the support and proper functioning of all the layers below it. Today I'm going to delve into each one of these layers, explain what they do, why they do it, and how to troubleshoot them. So why should you care about the 7-layer model? Because knowing the OSI provides significant practical advantages. As you can see on the slide, it provides a logical step-by-step methodology to help you isolate and identify the root cause of technology problems. It helps you pinpoint exactly where the problem lies, saving troubleshooting time. It also gives us a shared language to communicate with other professionals. It helps us understand the roles of different network devices and enhances our understanding of network architecture and cybersecurity. This is a foundational skill. So let's start at the very bottom. Layer 1, the physical layer. Is it plugged in? This is the tangible layer. This is all about the fundamental electrical or optical connections. Without this, data simply cannot physically travel. We're talking about the wires, the signals, the connectors, the actual stuff you can touch. Devices here include cables, power supplies, RJ45s, the fiber optic transceivers. So what are the common problems that scream, this is a layer 1 issue? You're going to see things like no link lights on a switch. This is a dead giveaway. Intermittent connections. It works, and then it stops working again. And then maybe it works again. Then the slow endpoint speed, even if the network should be fast. And the dreaded no cable detected message. All of these point to a fundamental breakdown in the physical transmission. The solutions for layer 1 are often the simplest, but also the most crucial. Try pushing the cable connections. Seriously, it works more often than you think. And have them tug on the cable a little bit. Maybe it's going to fall out and it wasn't really in. Swap out the cable. Cables go bad sometimes. Cycle the device power, the good old reboot. Maybe it can reestablish a physical link. Clean the connections, especially for fiber optics, but don't touch it with your finger, just sort of blow it because dust can interfere with the transmission of data. And also check the cable distance. Exceeding limits causes signal degradation, so always start here. Now moving up, we have layer 2, the data link layer. This layer ensures reliable address delivery of data within a local network. This is where the raw bits from layer 1 are organized into structured units called frames. And this is where MAC addresses are used to identify specific devices on that local segment. Devices like layer 2 switches, NICs, wireless access points, these all operate here. Symptoms of layer 2 problems can be a little bit trickier because layer 1 might look fine. So you might see things such as no communication between network devices even when they're on the same local network, or no network access even when you can see that the link light is on. Another one is not getting any DHCP IP assignment. The device can't get an address from the local server, or you can ping a local device, but you're losing a lot of packets along the way. These often point to issues with how devices are locally addressing each other or sharing network medium. To tackle layer 2 issues, verify the correct VLAN assignment for the device and its switchboard. Clear the ARP cache on the affected device to force it to relearn the MAC addresses. Update network adapter drivers and firmware on the NICs and the switches. And although rare, check for duplicate MAC addresses. This can cause intermittent communication. Now we get to layer 3, the network layer, where the packets roam. Layer 2 is all about using MAC addresses to route data within a local network Layer 3 is about enabling data to be routed across different networks globally, thus making the internet possible through logical addressing, specifically IP addresses. Routers are the quintessential Layer 3 device, along with Layer 3 switches and network firewalls. Layer 3 problems are usually evident when you can't get out of your local network. No communication outside of your local area network. You cannot ping a public IP address, such as 8.8.8.8, a clear sign that traffic isn't leaving your network. Firewall blocking, specifically rules based on IP addresses. And issues with routing protocols like OSPF, open shortest path first, or static routes, preventing traffic from finding its way. Solutions for Layer 3 involve checking the logical addressing and routing paths. Verify IP configurations using ipconfig on Windows and ifconfig on Mac and Linux. Ensure the IP, subnet mask, and default gateway are all correct. Ping Google's name server 8.8.8.8 to confirm you can reach the internet. Use traceroute to identify where packets stop along the path. Check for duplicate IP addresses, and this is especially true if you've statically assigned IP addresses. And meticulously review firewall and network address translation configurations. These are really common Layer 3 blocking points. Next up is Layer 4, the transport layer. Layer 3 was all about getting to the destination using IP addresses. Layer 4 is about how you get to your destination. This is where TCP and UDP come into play. So when data travels via TCP, the sender and receiver check in with each other to verify that all the data made it to the intended receiver. UDP, on the other hand, just fires and forgets. For example, sending email would be TCP. The mail servers verify the email got to the destination. Video, like this one, this is UDP. If it gets there, it gets there. The core of Layer 4 is software, firewalls, gateways, routers, and load balancers. Layer 4 issues manifest as problems with specific application connections. So if you're on an application and you see connection timed out or connection refused when trying to access a service, that's going to indicate it's a Layer 4 problem. Choppy or dropped connections, especially for real-time applications like video calls. Unable to sign into domain accounts, even if ping works. And generally slow applications, particularly those relying on a reliable data transfer. So here's a few common ways to resolve Layer 4 problems. Confirm the application or service is actually running on the destination server. Look for firewall problems. Are the application's ports open and allowed? For example, for email, ports 25 and 143 are very commonly used to send and receive mail. And if these aren't open on the firewall, then email can't work. Clear the DNS cache on the computer in command line. Incorrect DNS can lead to trying to connect to the wrong IP. And now on to Layer 5, the session layer. This layer establishes and manages the back and forth flow of data between applications. While much of this is software driven, some specialized proxy servers or gateway protocols can operate here. Active Directory's authentication in order to provide access to the resources in the domain controller also exists here. Layer 5 issues are often about what should be continuous connections failing. So video conferences that drop or freeze unexpectedly, choppy or dropped connection sessions, users unable to sign into their domain accounts even if their password is correct, and applications that require a constant back and forth flow of data that are operating slowly. So solutions for Layer 5 often involve things such as checking configurations inside the application itself for session-related settings. Also checking RAM. Sometimes applications struggle to maintain sessions if they're resource starved. If you see someone having trouble and they have lots of Chrome tabs open, closing the tabs can often free up enough resources to reestablish a session. And ensure drivers are updated. They can impact how applications manage sessions, so using Image Assistant here can be beneficial. Now moving to Layer 6, the presentation layer, this is the universal translator. This layer translates and formats data, including encryption, and prepares information in order for applications on different systems to work. This layer prepares data for Layer 7. So this layer primarily is handled by your operating system, software applications, and some various libraries. So symptoms of layer 6 problems are usually about data being able to be read. So on the screen, if you're seeing weird and unreadable text, or images not showing up and videos not playing, or if you're getting website errors, like the certificate isn't valid, and that's going to indicate that there's a problem with the SSL encryption or the certificate trust. So common fixes for layer 6 issues include checking the certificates and ensuring that they're valid and trusted. Certificates expire. Check the version of the operating system and make sure that it's up to date. And also update the application itself. It might be out of date and no longer contain the necessary codecs. So finally, layer 7, the application layer, the user's gateway to the network. So this layer provides the direct interface for users and applications to access network services, making networking useful. It's almost entirely software driven and resides in your end user's applications and your server-side application software. Layer 7 problems are what users complain about most frequently. Software application crashes, a specific website that won't load even if other websites will, emails not sending or receiving. These are all direct failures of the application itself not performing its intended network function. Solutions for layer 7 are very application specific. Check application settings, often it's a simple misconfiguration. Check user permissions within an application. Are they logged in using the correct account? Reinstall application software if it seems corrupted. And sometimes, simply just trying a different web browser to rule out specific software issues, such as using Mozilla instead of Chrome, will sometimes offer a solution. And finally, the unofficial but universally acknowledged layer 8, the human element. It's where many network problems mysteriously originate. We all know that about 70% of all troubleshooting can be solved by asking, did you try turning it off and back on again? Remember, the user is part of the system. So why is this layered approach so powerful? It's a way of thinking that applies far beyond just computer networks. Just like troubleshooting a network, you can use the systematic layered approach for electronic devices, whether it's a car, a water heater, an oven, or even a robot vacuum. Breaking down the problem into logical layers helps you pinpoint the root cause. I've successfully used this way of thinking to fix both the HVAC system and the water heater in my home. So you can see the OSI model is more than just a theoretical diagram. It's a practical, logical framework that will make you a more efficient, effective, and confident IT troubleshooter. By understanding each layer's role, common symptoms, and solutions, you're better equipped to tackle any IT challenge. Thank you.